Hey guys, this will be the homework for 5.4 and 5.5, and there's really two things that that you're being tested on here, and not tested on, but the homework is about first the first derivative test, and then the candidates test. So those are the two things that this homework assignment is on. And so for question number 1, it says let f be a differentiable function with a domain from 0 to 10. It is known that f prime of x, the derivative of f, is negative on the intervals from 0 to 2. So, to be honest, this is the first time that I'm doing this problem. And so right now, just what I'm thinking is I'm thinking about a number line. And a f has the domain from 0 to 10. So I'm trying to just think about what the domain of this function is. So I know that it exists from 0 to 10, and that on intervals from 0 to 2, it says that f prime is negative from 0 to 2 and from 4 to 6. So f prime is negative here and negative here, which means that the graph of f is decreasing here and here. And it's positive on the intervals from 2 to 4, so 2 to 4, and from 6 to 10. Which of the following statements is true? So again, if you're trying to visualize what the graph might look like, I think the graph is decreasing, then it's 0, then it's increasing, then 0, then decreasing, then 0, then increasing. So probably like maybe a W-ish shape. I don't really know specifics, but so it says f has no relative minima and 3 relative maxima. No relative minimum. So we have a minimum at x equals 2 because the graph goes from decreasing to increasing, and at 6. So I don't think A is going to be true. Don't think it's going to be A. F has 1 relative minimum and 2 relative maximum. Again, it has 2 relative minimum, so it's not going to be B. F has 2 relative minima. I think that's true. We're going to have minimum at 2 and 6, and 1 relative maximum. So we have a maximum at 2, because we go from, we have a maximum, sorry, not at 2, we have a maximum at 4 because we go from increasing to decreasing. Okay, and then, so 1 second, so we're decreasing, increasing, decreasing, increasing. So 2 minimum values and 1 relative maximum. It can't be D, that's for sure. So it says it has 3 relative minimum. No, we only got 1 and we got 2. And then we do have a relative maximum. So it's got to be C. And that checks out with how this is being graphed, right? So we got the relative minimum, 1 and 2, 1 relative maximum. I guess we're not talking about the endpoints here. So, okay. So yeah, it's got to be C. For 2, so this is calculator required. Let f be a function with the derivative given here. Which of the following statements is true? So let's go ahead and look at the derivative of this. We can go ahead and graph this. So we've got x raised to the third, and then minus 3x, and then minus 2. And for the window, let's just do a standard. That's not standard. Go to window 3. Okay, so remember that this right here is f prime. It's not the actual graph of f. And so what I can see here is that the graph of f prime is negative from negative infinity until negative 1. And then it's negative still from negative 1 to positive 2. So again, if I'm kind of giving if I draw a number line here, so we have it looks like at negative 1, and at 2. So f prime is negative here, then it gets to 0, and then it's negative again, and then after 2 it's positive. So this is the graph of f prime. And so this means that the graph of f is going to be decreasing, and then it goes to 0, but then it still continues to decrease, and then we finally go to increasing. So this is what the graph might look like right here. This characteristic is called a shelf. It's where the function goes from decreasing or increasing to 0, but then stays the same sign afterwards. Okay, and then it's going to go like that. So this is what the graph of f will probably look like. And so looking at A, it says f has no relative minimum and one relative maximum. That's not true because we do have a minimum. Okay, and I don't think we have any maximum here. So for B, it says f has one relative minimum, true, and no relative maximum. So I'm thinking it's got to be B, not A. Let's go ahead and read these other options. F has one relative minimum and one relative maximum. So no, I don't think that's true. I don't think we have any maximum. So there's no maximum. We have a minimum here, but no maximum. So not C. And then F has two relative minimum. Nope, it did not have two relative minimum. It just had one. Just one. Okay, for 3, the function f is defined by f of x equals x squared e to the negative x squared. At what values of x does f have a relative maximum? So, just like all these other ones, we're using this right here is called the first derivative test, right? We're using the first derivative to prove to see where a function is increasing and decreasing, and that's going to help us find relative minimums and maximums. Okay, and so that's what we're doing here. So I need to find f prime in this case since it's not given to me. And so f prime of x, we're going to have to use the product rule here and chain rule. So we're going to take the first, which is x squared, times by the derivative of the second, which will be e to the negative x squared, and then I have to multiply by the derivative of the inside, which would be negative 2x. So that's the first times the derivative of the second plus the derivative of the first times by the second. So that's e to the negative x squared. And so now that I have f prime, we're supposed to set this equal to 0. Now, just as like it's very common that if I have e to the x squared and I'm setting it equal to 0, it's very common just to factor these out because they'll never be equal to 0 a lot of the times. And that's going to be the case for e to the x squared. So you can factor out e to the negative x squared. Again, there is no value of x that's going to make that equal to 0. So then I'm going to be left with x squared. Well, one second. I can multiply these two terms together. I just factored that out. So that's going to be negative 2 x to the third, and then plus 2x. And that's going to be equal to 0. And then I'm going to factor this even more. It looks like I can take out... I'm just going to take out an x. Maybe I can take out a 2x, I guess. So I have e to the negative x squared. I take out a 2x, and I'll be left with negative x squared plus 1, and that will be equal to 0. And so this expression, since I have products, I can use the zero product property. So either this is, we already established that that's not going to be 0, but this will be equal to 0 when x equals 0, and this right here will be equal to 0 when x is equal to plus or minus 1, right? So if x is equal to 1, this will still be negative 1. And if x is equal to negative 1, this will still be negative 1, making that equal to 0. So my zeros are negative 1, 1, and 0. Okay, so I'm going to keep that. So x is equal to -1, 0, and 1. So I need to move this over. Definitely not a whole lot of space here. But so I'm going to use the first derivative test. So we have -1, we've got 0, and we've got +1. So using the first derivative test, I'm going to plug values around these critical points, and that's going to tell me if the function is increasing or decreasing, which will in turn tell me if I have relative minimum or maximums. And so let's test, let's plug something in like -2. So if I plug -2 into the derivative, I can plug it into any one of these. So let's say I plug -2 in here. So if I plug in -2 here, -2 squared is -2 squared is going to be 4. So e to the -4, but that's still going to be positive because that's 1 over e to the 4th. And I'm pretty sure that e to the x squared is -x squared is always positive. We can check on a graph. So we've got e raised to the -x squared. Yep, you can see that this is always positive, so that's good to know. So this will always be positive, okay? But if I plug in -2 here, this becomes negative, so I'm going to keep track. That's going to become negative, and this is always positive. What happens when I plug in -2 here? So that's going to become -2 squared, which will be 4 times by -1. So this is -4 plus 1. That's going to be -3, so still negative. So I have positive times negative, which will be positive. And so this means that my graph is increasing here. Okay, now let's check, let's say -1/2 or something. So if I plug in -1/2, so again, that's always positive. If I plug in -1/2, that's going to become negative. And if I plug in -1/2 here, so this -1/2 squared will be 1/4. This will become -1/4 plus 1, which will be a positive number. And so that means that positive times positive is going to be negative. So that's going to be negative there, which means that the function is increasing. So we do know that we're going to have a maximum, relative maximum at -1. So, I mean, in short, it has to be D because it doesn't mention -1 anywhere else. And so let's just check here. It looks like the other one's going to be at 1. I'm going to assume, so let's check if I plug in 1/2. So if I plug in 1/2, so 1/2, this is always going to be positive. If I plug in positive 1/2, that's going to be positive. And if I plug in 1/2 here, this is still going to be positive. So it's got to be positive here. And then if I plug in something like 2, that's positive. If I plug in 2 here, that's positive. If I plug in 2 here, this is going to become -4, so that's going to become negative. So negative. So the function is increasing, decreasing, increasing, decreasing. So at what values of x does f have relative maximum? At -1 and at +1. So yeah.